So, a couple of quick terms. Remember, the 3 is the base. Obviously, the 4 is the exponent. And then we'll call this 81 the result. But in terms of log terminology, it's called the argument, which is kind of a weird description of it, but that's what we call it. In log form, basically we're taking those numbers and just rearranging them into the notation of a logarithm. So in a logarithm, and we're going to put this in your notes in a second, we write the base in subscript down below the word log. And there's 2 exceptions to that, but typically we write the base number down below the word log. Okay, and then the result goes next to the word. Now I've written out base, kind of it looks long, but that's usually just a number, like 2 or whatever. So the argument goes here. And then the exponent, and so that's also the result, remember. The exponent goes over here. And basically what you're saying is, if I take this base to this exponent, I get this argument, that's exponential form, or I get that result. In log form, we're saying, what power of this base gives this result? Okay? So for this one, in log form, it would look like log base 3 of 81 equals 4. And what that tells you is 3 to the 4th power is 81. Okay? So you're going to get more familiar with your powers in this part of the unit, a little bit at least. So what you could ask the question, what power of 3 gives 81? If we didn't have this written here, what power of 3 gives 81 is the question that this is answering. And so you can see that it's going to be important to be able to go back and forth between log form and exponential form, especially when you're first learning what this notation means, because it is a little bit weird. Any questions on that? Okay, grab your notes. Let's put that in there. On your calculator, they try to match a function and its opposite or its inverse on the various keys. They don't do that throughout the whole thing, but typically. So like you'll see the square root with the squared. Those are inverse operations. You'll see log with 10 to the x. Those are inverse operations. So here's the question it answers. So it answers what power, maybe even just underline that, what power of the base gives the result. And then we'll write the notation next. Let me raise this up for you. It's going to take you a little bit to get familiar with the notation, so I would recommend studying it. It's not hard, but it's just different. So we write the word log, mostly. There is one version. You guys remember continuous compounding? And what was the base of it? E. So E has its own logarithm. Otherwise, we write the word log. Okay? And then the base, like I said, goes down below. It's subscripted. You do need to get in the habit of writing it as a subscript. You don't need necessarily the parentheses, but sometimes you'll have them. And then on the other side is the exponent, or power. Which one do you guys tend to use more to yourself? Do you say power or exponent? Exponent. Okay. And then I do want to write this. I think it's really helpful to connect this to exponential form. so that you can kind of see the connection. And the words are kind of obviously longer than the numbers that go with them. Okay, so I'm just going to write in here from exponential form. Okay, so that's words. We're going to rewrite it now with just letters so you can kind of see this more, hopefully more familiar. So it will look like this, log base b of x, or not of, but sorry, of r. What should we use for that? Seriously, this isn't right. Give me a second. I want to stay consistent with what they are using. C. I don't know if I want to actually do that. Oh. Okay, so that's log form, and then exponential form. Just move stuff around and take out the word log. So you'll have b to the x equals c. And c is some number. Okay, you're starting to kind of see the connection. We can start with a couple easy ones to help you. One of the things that we'll kind of ease into is evaluating these, and eventually we'll solve for x. But I would spend some time studying these two boxes, okay? Because it all depends on you being able to interpret this notation right here. And you won't be able to do that if you don't spend a little bit of time on it. Any questions on that notation? Yeah? No?
No.
Okay. So let's do another one. It says, what is the exponential form? So now we're going back the other way. So let's identify the pieces, and I can use, like, 10 is the base. It's down below. We call that subscripted. 1,000 is the result or the argument, and 3 is the exponent. Okay? So in exponential notation, this would be 10 to the third equals 1,000. Which, hopefully you kind of know, 10 to the third is 1,000. Good? All right, so where does this become a little bit more tricky? Well, we saw on that earthquakes, what was it? Seismograph? No. Magnitude. Anyway, we saw on there, we had 10 to the what power equals 5,500. Okay? So now I want you to rewrite this in logarithmic form. And I'll show you what you can do to evaluate that. 10 to the what power is 5,500. How would we rewrite that in logarithmic form? Yeah, Lena.
Log of 10.
You say the base first. So log base, then you say the of.
Log 10 of 5,500 equals x.
Awesome. Okay? So once we rewrite it this way, do you see how we can, this is, all of this side is something we can plug into the calculator and solve. Okay? So grab your calculator, and I want to point out something right away. Over here on the left by the 7, you see the word log. Okay? First thing you need to know before you just start using that button that is log base 10 only. So if we were solving for something else, like I'll show you an example in a minute, you can't just directly use this button. But for this problem we can because it happens to be log base 10. Notice right above it is its inverse, which is 10 to the x. So like I told you a bit ago, those are always combined with their inverse function. Just like square root unsquared right above it. Okay? So if we want to do log base 10 of 5500, we put log. It knows that that's base 10 and it doesn't show it. We call that common log. And then we just punch in 5500 and it's 3.74. You guys remember trying that yesterday? You kept trying numbers and we eventually landed on roughly the 3.75. Okay? Well, now we have a button for it. Okay? And that tells us what power of 10 gives 5500. What power of 10 gives 5500? And that is 3.74, some other stuff. Okay? So, that was a base 10 one. Here's what I was saying. If I asked you this question, log base 3 of 27, actually that's too easy. How about 40? Can you go punch log on your calculator? No, because this is now base 3. Okay? So there is a function in your calculator that will switch and do that. In fact, let me just show you it. Okay? So you're going to have to hit math, and then arrow to number. Arrow, there we go. Is it on here? Nope. There it is. So it's under just math. So just hit math and go down to A. And it's log base. Now, not all calculators have this. So if yours doesn't, you're going to have to tell me. But we'll learn a formula to do a base switch. Hopefully you have this on yours. And do you see how, does yours bring up the format where you can just plug in the numbers? Yeah. Okay. So we wanted to do log base 3. Don't do it yet, please. I want you to estimate of 40. So what power of 3 do you think would give 40? Like ballpark it before you punch it in. So 3 to the first is 3. 3 squared is 9. 3 to the third is what? 27. 3 to the fourth is 81. And we're trying to find 3 to the what power is 40. So what are we going to ballpark that at? 3 point what? 7. And what were you saying? 3.35. We all agree it's between 3 and 4 for sure, right?
Cheater, no. Cheater.
Wow, he must have really known that.
Cheater.
3.36. We'll go with that. Okay, but point is, even though this is a new concept, if you understand the notation, your intuition can tell you kind of a ballpark for where these should be. Okay? Let's do another one. What if we said, solve this equation? 6 to the x equals 200. How would you write it next in order to solve that? So we're going to rewrite as log what? Base 6 of 200 to get x. In other words, it isolates x for us, right?
Yeah.
So what do you ballpark that at? Well, 6 squared, I'm going to just jump to that, is 30. Oh, wow. 6 squared is 36. 6 cubed is 206. Okay, so that's just a little bit higher than that. So it's got to be just under 3. Okay? I'm going to go with Shiley and say 2.95. Okay. Starting to make the connection a little bit. Yes?
Yes.
Based on what Lena was saying, I think it would be worth writing what this says in, like in English, so that we can communicate effectively. Okay. So log base, whatever b is, we just did one. Log base 6 of 200 is 2.95. Okay. So let's make sure we're saying it correctly when we do it. So what me asking you, like roughly what power of 6 gives 200, that's called evaluating a log. Okay? So let's do a couple ones that you should know right away. Log base 5 of 25. Don't shout it out. Log base 5 of 25. Don't do it incorrectly. You should know this. Log base 5 of 25. I mean, Blake held it up in like half a second. Yeah. Okay, good. 2. Right? What power of 5 gives 25? That's 2. Good. Right? Let's do log base 10. So common log. Log of 100. Again, it's 2, right? 10 to the second power is 100. Okay? Now, I've said this one today. Let's see if you picked it up. Log base 3 of 81. Okay. 4, right? 3 to the 4th is 81. Good job, guys. You're picking this up. Nice. Wanna up the level a little bit?
No, actually I don't.
What? It's writing it in log form is no big deal. Here's my question. Why is this true? Why can I take a fraction to a negative exponent and get a whole number that's way bigger? What? It's important to know. Okay. In fact, let's write this one in your examples. Maybe we could put a couple different ones on here. Okay, what power of 7 would give 400? I mean, ballpark it. Well, 7 squared is 49. Times 7 is roughly like 350. I mean, it's not quite. It's like 343. And I'm asking for 400, so it's got to be between 3 and 4, right? Okay? What did you guys say? Well, I heard 2 and 0.75, so. Should we split it? Okay. Rewrite in log form, which looks like what? What's our base? Log base 7. What's our result? 400. What's our exponent? We don't know. That's what we're trying to find. And then go punch it in your calculator to get what? Somebody do that for us and tell us what you get. Okay. Good?
Have you ever used this in your life?
Outside of school?
Yes. Don't lie. Yeah, we're just practicing at home.
I'll tell you this. So this is how you solve for, let's say you're close to graduation. Let's say you're like, well, if I start saving and I'm making interest on some money that I get, how long will it be before I have X amount of dollars? So that's this, right? Like, here's what that would look like. Let's say I want a $10,000 down payment on a house, and I'm just putting in $5,000 when I graduate high school. And I'm getting, I don't know, let's say you're getting 5% interest, compounded monthly. T, there's that variable in the exponent that I haven't been able to solve for. Right? So you can divide. This is a number that we can use as our base, and then we can log to get that down to solve for t. And then it will tell us exactly how long we can expect to wait if we're just relying on interest. That's the kind of more realistic side of this. Or maybe like, hey, when will Grand Junction reach 160,000 people? If we're basing it on the current growth rate. That kind of stuff is where this is helpful. Anyway, let's estimate. Well, this is 1 to the x over 3 to the x to get 27. Well, 1 to the x is just 1, right? So it's still just 1 over 3 to the x equals 27. I do want to put a reminder here. Negative exponents do what? They switch position, top to bottom. And change sign. Of what? Of the exponent. So this is going to require a negative exponent in order to make a bigger number. So I'll let you write that. That was a little bit long. So okay, we'll rewrite. What's the base? I mean, we need to write the word log, but what's the base? It is 1/3. So 1/3. What's our result that we're trying to get? 27. And then, of course, that gives x. So that can go in your calculator. Do practice punching in a fraction as a base, though. That's a good thing to try. Thank you, Tal. So 3, actually, let's get everybody at this point, and then I'll explain it. Okay, here's what the note in the top right says. 3 to the negative third in the denominator goes 3 to the third in the numerator. So it switches position, goes from denominator to numerator, switches the sign of the exponent, and then 3 to the third is just 27. Okay, that's how that works. So what would 3 to the negative third be if 3 to the negative third? I'll just write it. What is this? It's currently in the numerator, right? So where does it go goes to the denominator as a positive exponent, which now it becomes what? 1/27. Do you see how there's no sign change? This does not make it negative. Ever. It doesn't change the sign at all. You guys need to quit talking, please. Right? 1/27. Guys, that's something you're just going to have to get. Like, there's nothing hard about it. You just have to take time to get it in here. And then quit making the mistakes. Alright. What power of 5 is 125? What power of 5 is 125? That's what that's asking. 3. Okay, let's try this one. What power, don't shout this one out. What power of 1/4 is 16? That's just like the example we just wrote. We're turning a fraction into a much bigger whole number. Can you do that with a normal exponent? No. So what do we have to do? Well, it's this. I want this to move from the denominator up to the numerator. How do you move something? You have to have a negative exponent, right? To switch position. So this is really, I'm going to move the 16 over. 4 to the negative x equals 16. So we can switch position. So this has to be what? -2. Okay? Now this didn't have an x, but that's okay. Here's an interesting one. What does it ask? One person, raise your hand and tell us what this says. And you can use your notes for that. It starts with, go ahead. Okay. Okay, I'm looking right here in the notes. We just wrote it in quotes. We need to switch it, so too much scrolling. What power of 3 gives 0? Right? This is what it's asking. Raise your hand when you know. Come on. This is a test if you really understand this unit at all. And so far nobody does. Well, I don't know what mine is. You're just holding their hand up. Good job. What power of 3 will give 0?
Where's your number?
What? So 3 to the 0 is 0? 3 to the first is 0? Three to the third is 0?
Let's do a negative number. Can you just tell me?
Oh my goodness. Actually, yes, Riley does. Actually, probably all 3 of those dudes do. Is there a way to put an exponent on a number and make 0? There's no way, right? There's no way to make 0 by putting an exponent. Okay, next question. Can I put an exponent on a number and make it negative? No. You can't. Because, think about this. Remember our exponential function? Why is it not writing? Does it ever reach 0? Does it ever go negative? So can I put an exponent on something and make it 0? So what would we call this?
Shake.
Okay. Punch it in your calculator and see what your calculator says. It's just log base 3 of 0 is what you're putting in.
Quit. Okay.
What does the TI-84 say? Yep. Because the domain for a log never comes to the left or 0. And I'll show you that when we get to graphing a log. But okay. How are you doing with this? Besides that one. Should we write in your notes you can't make 0 or negative number with an exponent? You sure? I was serious. Do you want to put that as a reminder? Oh, you can probably expect something. Alright. Don't overthink this. You have 5 seconds. Log base 2 of 2 to the 8.
Stop.
What is it asking? I think we should write that in your notes because that seems to be a breakdown. What power of 2 gives 2 to the 8? What power of 2 gives 2 to the 8? Is 8.
8. Oh.
What power of 2 gives 2 to the 8th power? Well, it's just 8. So this problem points this out. A log base and an exponent base cancel each other out. That's the inverse operation. Okay? Let's go write what this question asks. I think that's going to need to go in here as a big deal. Okay? What power of 3 gives 81, etc. Like that's going to be just an example for how to read these. And finally, today for this, that doesn't mean we're done, so don't pack up. So a log with the same base as an exponential. I'm putting this in quotes, but it cancels each other. And we can just put several examples like the one we just saw. So log base 2 of 2 to the 8th is 8. Log base 4 of 4 to the 3rd is just 3. Etc. They just cancel each other out. Okay? I don't know how many of these you want, but what if we did log base e? We'll have a specific name for that, but for now I just want to write it as log base e. Okay, they just cancel. Log base pi. What if you had a base of pi? Huh? If it was pi to the 4th, it would just be 4. Yeah, so it cancels. As long as it has the same base, that's probably worth underlining. Are logs weird? A little at first? Alright. So what we'll do from here is we're going to work through some of the SAT problems. You're going to have SAT problem homework. I'll post it because I'm not going to print like thousands of pages, so I'll just have you look at problems posted on Google Classroom. And I will put it in as a grade, just like normal homework. So this is geometry. This is going to be one of your homework problems tonight. But before we go, I want to review a little bit with you, see what you remember about this kind of a figure. Notice it says lines A and B are parallel. So I'll remind you that parallel has arrows is the notation. And if there were multiple sets of parallel lines, how would that look? Well, we'd have like multiple arrows, right? Okay. All right, where can we copy the 123? She said down, so we can put 123 here. Where else?
Right.
Here. What kind of angles are those? What are they called? Starts with a V. Vertical. Okay, vertical angles. These were corresponding angles. How about from here to here? Those also have a name. Yeah, good job. Alternate interior. So where else can we put the 116?
Right.
Top right, 116. This whole thing, 116. I need to do 2 there. Guys, it's kind of annoying when you're packing up while I'm trying to help you out here. 81 can go where? And then how do we get this angle right there?
Subtract 81 from 180.
Good, that's a linear pair. They're also called supplementary, so you can subtract from 180 to get 99, and then copy it where you can get that. Okay, so I will put a copy of this as one of your homework problems. And then also this one. Do you guys remember absolute value equations? Just a quick reminder. We drop the absolute value and we set it equal to the positive version of the right side and the negative version of the right side. And then just solve those like normal. For this one, you need to get rid of the 1/4 and the 30 before that step occurs. Okay? That's all I want to tell you at this point. Just let you think through the rest of it. Okay, these are actual SAT problems. These are not just randomly pulled review problems. So, we do need to address some of these. There will be a few others that are easier than this. So, you need to upload a photo just like normal. But it'll just be all posted with SAT stuff. Sound good?